So 12th standard physics. So in this class we are going to discuss about Faraday's experiments on electromagnetic induction. So he conducted two experiments to demonstrate the electromagnetic induction. So first one, so there is a coil is connected with the galvanometer. So galvanometer is used to measure the minute current. So that is sensitivity is somewhat more compared to ammeter. So there is a coil is connected with galvanometer, then a bar magnet. So the bar magnet facing north pole. So it is inserted inside the coil. So we are moving with certain velocity. We are inserted inside the coil. So consider this is a bar magnet. So facing north pole. So it's inserted fast with velocity v1. So there is a momentary deflection in the galvanometer. That means so it initially so there is no deflection in the galvanometer. So now we are using a bar magnet moving with velocity. So it's towards that is north pole facing the coil. So we are fastly inserted inside the coil. So there is a momentary deflection in the galvanometer. That means there is a current flow or current setup in the coil. After that we are placing stationary that bar magnet. So there is no deflection in the galvanometer. There is a momentary deflection in the galvanometer. Now again, so next, so again now I am going to remove or withdraw the bar magnet away from the coil. So there is again a momentary deflection, but it is in opposite direction. So what is the direction of flow? So I am inserting fast. So the direction of deflection in, so we are inserting fast from right to left, but the deflection in from left to right. So it is in opposite direction. Now I am removing or withdraw the bar magnet away from the coil. So again the deflection in opposite direction. See, so it is towards right to left, here left to right. So it is in opposite direction. Then what I am going to do, again I am moving very fast, inserted into the coil. So the bar magnet north pole facing the coil very fast. So with velocity v2 is greater than v1, then we get a larger. So see the deflection here. The deflection is somewhat low. So the galvanometer is from 0 to maximum. So up to this. Again here the deflection is somewhat more compared to v1. So v1, the larger deflection means that is greater protection of current. So we are inserted fastly, that is north pole facing the coil. We get a greater current flow in the circuit. Now I am going to reverse the circuit. I am going to reverse, that means that is north pole facing, now the south pole facing the coils. Again I am doing the same set of experiment, but I get the results opposite to the previous. So if it is south pole, again see the deflection here from left to right, here right to left. So this is the difference between the equation, that is north pole facing the coil, then south pole facing the coil. So what is the result? Now I am going to do the somewhat different. So the magnet is at rest. Now I am moving the coil fast inside the bar magnet. So the same result I will get. So again same thing. So if it is at rest, the bar magnet is at rest, I am moving the coil, or the coil is at rest and I am moving the coil, or I am moving relative to one another. So both bar magnet and coil. So consider this as a coil. So I am inserting fast. So both are moving. So there is a relative motion between coil and magnet. There is a deflection in the galvanometer. So current is set up in the coil. So this is a first experiment results. So there is a relative motion between the magnet and the coil. There is a deflection in the galvanometer. That means it shows there is a current set up in the coil. This is the experiment number 1. Then second experiment. So consider a coil with the battery and key. This is the primary circuit. Then secondary circuit, again one coil with connected with the galvanometer. Now so what is the difference between the experiment number 1 and 2? So we are using the bar magnet here. So already we know the current carrying conductor acts as a bar magnet. So current carrying loop. So I am closing the circuit. So the K, that is K is a key. I am closing the circuit. So current starts flowing inside the circuit. So current carrying conductor, around the current carrying conductor there is a magnetic field that is perpendicular to the flow of current. So it acts as a bar magnet. That is the concept behind that. So now the primary circuit and the secondary circuit, the proximity is somewhat closer. Just see, the primary circuit and secondary circuit are somewhat closer. So if the circuit is close, so current flows inside the circuit. So there is a momentary deflection. So current flows inside the circuit. There is a deflection in the Gauss meter. So now we are closing the circuit. There is a current flow inside the circuit. That means there is a current flow from 0 to maximum. So it reaches a maximum value. So inside there is a momentary deflection from changes from 0 to maximum. There is a deflection in the Gauss meter in this side. Now again I am closing. So the circuit is closing. Now I am break the circuit. That is open the circuit. This is a closed circuit. It's a open circuit. So current starts decreasing. So current starts decreasing means again maximum to 0. Here 0 to maximum. So there is a change in current. That means change in current. There is a change in magnetic flux. So there is a momentary deflection, but in opposite direction. Here it's in from left to right. Here right to left. But again it reaches to 0. So current reaches to 0 or current reaches to maximum. There is no deflection in the Gauss meter. But so current starts increasing from 0 to maximum. There is a deflection. So current starts decreasing from maximum to 0. There is a deflection in the Gauss meter. So there is a protection of current due to the primary circuit. So that is the electromagnetic induction. So we can conclude. So whenever a current in the primary circuit changes, so there is a change in current from 0 to maximum or maximum to 0. There is a Gauss meter source deflection. That means there is a current is set up in the circuit. So from experiment number 1 and 2, so Faraday explained the electromagnetic induction. So experiment number 1 shows so relative motion between the coil and the magnet, deflection in the Gauss meter. So it shows the current is set up in the circuit. If it is move the magnet very fast inside the coil, so there is a protection of current in the circuit. It shows through the Gauss meter. Or we are withdraw, the deflection is in opposite direction. If it is at higher velocity, so larger magnitude of deflection, that means greater current. Then in the experiment number 2, we are closing the circuit. We are broken the circuit. If it is closed in the circuit, the current flows inside the circuit. So current increases from 0 to maximum. So whenever there is a change in current in the primary circuit, so there is a deflection in the secondary. So that is in the Gauss meter. So these are the two results we get from experiment number 1 and 2 through the experiments conducted by Faraday. So okay students,